Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard, at Richard on the MakeCode forum.
I'm Daryl, at Daryl on the MakeCode forum.
I'm Joe, at J1Drill on the MakeCode forum.
I'm Shannon, at Shakao on the MakeCode forum.
And I'm Vivian, at LiveTriff on the MakeCode forum. Not cutting Shannon off today.
Good job, Vivian.
Thank you.
All right, so today, by request, we are doing a JavaScript stream. And we're not even just going to do like a normal JavaScript stream. We're going to like get into it, guys. We're going to like go deep into the JavaScript. And my plan, and I don't know if we'll be able to achieve this in one stream, but I'm hoping we can, is we're going to write an extension today. And the extension is going to be movable platforms. So, you know, platforms that your character can jump on and they'll keep moving. So I've actually implemented this in Arcade before, but I did it for a different physics engine. I did it for my slopes physics engine. If anyone's ever seen my game on the forum that has, you know, like slopes and stuff. So I have an idea of how to do this, but we're going to see if it's going to work. Yeah, so, you know, stay tuned. You might learn some interesting stuff about the how Arcade works and how the internals work. But let's get started. So I'm going to first start off by, inside of my projects, I'm going to do a new project. We're going to call this name, we'll just give it like, you know, Arcade Moving Platforms. And maybe I should clarify what I mean by moving platforms. Mm-hmm. It's like, you know, like you can imagine it's like a thing that moves around and your person can like jump on it and ride it and it can like push you around and all of that stuff. That sort of makes sense?
It's like a car for the sky.
It's not really a thing that exists in real life now that I'm thinking about it. Like I've never thought about it before, but it exists in every single platformer game, so that's kind of weird.
Yeah. All right. Actually, I'm going to, well, no, actually, I think I need to do this in a blocks project. It'll be fine. We'll have to do something later to turn this into a normal extension because normally when you start an extension and you're writing it in TypeScript, you don't want to do this in the blocks editor. And the reason why is that when you're going into scene and you create a tile map, it's going to create a bunch of tiles in your project, and they're going to have the same name as someone else's project that has the same tiles, and you're going to run into trouble. So don't do that. But today, it's just going to make testing this game a lot easier. And so I'm going to do it. And then I'll take the code and I'll put it into another project that I'll then do as the extension. But having it inside of a blocks project for now, because I get access to all of the tile map editor and everything, is going to be really helpful. And so before we get started with the actual code, I'm going to start out by just making a platformer. So this is going to be our little test game. So I'm actually going to go ahead and just make a character. Yeah, right. I'm going to do one real quick. We'll do this 8 by 8. And I'm just going to do my classic character, the character that features in my slope game, actually. Give him some eyes. Make his legs closer together. Give him some hair. All right, this isn't quite the guy who's in my slope game. This guy's more Elvis-y, but I'm into it, so I'm going to leave it. He's got a sweet pompadour. All right. Now, we're just going to do this real quick. Let's rename this to be player. All right, the player. We're going to do controller. We're going to do move with buttons. So let's go ahead and do that. We don't want to do the Y direction. We just want to do X. We're going to make a tile map real quick. So let's just do one screen. So we're going to do 10 by 8. We're going to just fill it in with some of the default tiles. So let's see. We'll do the aquatic tile set. What am I looking for? Wall, right. And just so that we have some more stuff to test with, you know, I'll put something up here too. right, let's give it a background color because I like it when we have background colors. Looking good. All right, now we're going to take our sprite. We're going to give them some gravity. So go ahead, change this to the player, change this to AY, change this to be 500. And now we're going to do on A button pressed, we're going to do a jump, and we're not going to do our normal jump logic because this is really just for testing. I'm just going to go into the sprite. Actually, I can just take this. I'm going to take their VY, and I'm going to set it to be -200. Let's see if that works. Jump, jump. Cool, perfect. Yes, Vivian.
Vivian,
Daryl was asked a question in chat, which is, hello, how are you?
Oh, I'm okay.
Not you, Richard, Daryl.
Doing well. Yeah.
I'm glad you're okay, Richard.
Talk about Daryl. It's fine.
but they didn't care at all about how Richard is.
No, I get it. I get it, Joey. Message received. All right. This is our game. So we've got our basic platformer stuff, and we're gonna go to JavaScript now, and do what we promised. So I'm gonna go ahead and go into here. I'm going to do add a file to this project. Oh, whoa, I'm going way too fast. All right. So I'm switching to JavaScript, and when you're in JavaScript, you can see you've got your code that you've written in blocks, but over here we've got an Explorer, and this shows us all of our different files in our project. And so this tilemapg.ts and tilemapg.jres, those are the files that are going to give you errors in a blocks project. So I would not want to see these if I was doing this as an extension. But like I said, I'm going to do the extension later. So we're just going to leave this for now. What I'm going to do now is I'm going to click this plus to add a file. And we're going to be working on the physics engine. So I'm actually going to take this and I'm going to do physics.ts. And then do go ahead. And you can see we now have this file, physics.ts, that I'm inside. If I want to go back to my other code, I can just click main.ts again. And even when I'm in this file, the code's still there. If I play the simulator, I can still play with this test code. So, cool. All right. Now I'm going to make a namespace because when you're writing extensions, it's a good thing. It's a good practice to put your stuff inside of a namespace because that makes it so that you won't use any of the same names as the user's code, right? Because if I just called this like platform and someone had a variable named platform, then if they added my extension, they would have an error. So I'm calling this moving platform and hoping that no one's gonna, run into this. All right, and so like I said, we're gonna go deep into it today. So we're actually gonna be modifying the physics engine. And I'm going to now copy and paste a bunch of code that I have off screen, which is the physics engine. And maybe we'll talk about it a little bit.
I feel like we're basically like a cooking show, We have this prepared code that we did before.
Yeah. That first part where Richard made a new file and he typed in namespace was him like preparing it and putting it in the oven. And then he just walked over right to the right of that to the other oven that he has and pulled out the full physics engine that he had already written.
Yeah. Jerry wrote more of this than I did. I wrote the first version. Actually, Dina wrote the first version. I kind of wrote the second version, and then Jerry and
I think I wrote the third and fourth.
Yeah, something. I don't know. It's gone through a lot of versions. All right. So I'm going to briefly go through this code, just so we have an idea of what's going on. But first, we're going to make sure it compiles. Yep, we're all good. So I've added this class, and this is the same as it actually is in Arcade. So you're actually looking at the Arcade game engine code right now. All right. So this physics engine has a bunch of things where it keeps track of the sprites. And there's also this thing called sprite map, which is used for tracking where sprites are within the world. Basically, this just puts them into buckets. So it's like, create a bunch of buckets in the screen. Like if you imagine the screen was divided into 6 parts, then we'll say this sprite is in the center bottom bucket. And that just makes it so that if we're checking like collisions, we can just be like, okay, I only need to check the ones that are in the same bucket as me. Because, if I have sprites over here, I don't want to check them to see if they're colliding because they're too far away. So this just lets us be smarter when we check for collisions so that we take less time. All right, now, like like I said, I'm going to be going through this kind of quick, but some things to know. We have fx8. So this is just a number. You're going to see it a lot, and you're going to see a lot of stuff, but just know that this is a number. We store it in a special format to make it so that it runs faster on hardware. But an fx8 is just a number. Let's see. We've got a bunch of stuff about min step and max step. That's just for how far you can go in a single frame. We have some code for adding and removing sprites to the physics engine. This gets called automatically when you do sprites.create. And then here's the really important stuff. This is the move function. And so the move function takes in how much time has passed, and then it goes through all of the sprites and moves them. There's a lot of logic that happens to make that happen. We do a lot of stuff to see, like, are they colliding with something? If they move, did they hit a wall? If they moved, are they now overlapping with something? Do we need to fire an event? All of that kind of stuff happens inside this function and inside some of the other functions around here. So we have like sprite collisions, which deals with collisions. We're not going to mess with this at all. And then we have tile map collisions, and this we are going to mess with a little bit. Actually, I don't think we're actually going to change this function. I just need to be able to call it, which is why I had to duplicate this code.
Oh, okay. Oh, why is it private?
Yeah, I know. We have this bad habit of making everything private, because if it wasn't private, I could just extend it. But whatever. That's a.
I'm gonna write my. I'm just gonna do some spec channeling.
All right, yeah, let's do it. Yeah, no, I'm gonna be doing a release to common packages soon anyway, so you should do that. All right, cool. Okay, so I just wanted you to have a little bit of look at this code so that while I'm doing the other stuff, it might make a little sense. We're not actually going to touch it right now. What we're going to do now is we're going to create another new file, and it's going to be called Moving Platform. All right. Okay, so I'm going to copy my namespace because I want to make sure that I'm using the same one in both my files. And all right, so this moving platform is going to be, I'm going to make a class called Moving Platform, which is going to actually be the platform that shows up in my game. And this is going to have a few kind of properties with it. But the first thing I'm going to do is I'm going to make it so that it's a sprite. So I'm actually going to extend the class sprite. And this is the same sprite that we use in our other things. We're, instead of like doing what the normal sprite stuff does, like drawing an image that it has, we're instead going to be making a sprite that has a tile map, and we're going to be drawing the tile map. So the way that we're going to do these moving platforms is every moving platform is going to be a tile map. Sounds weird, but it makes sense in a second. It'll be a tile map that is like 4 by 1, you know? So like this could be a platform right here. And so it'll be like a really small tile map. But then we're going to change our physics stuff so that when we do our collisions with the other tile map, we also just check all of the other tile maps that it could be hitting, and then we'll kind of do the collisions that way. And so, yeah. If anyone has any questions in chat, can you guys read them out to me? Just so you know, like, feel free to throw anything my way. I know this is going to get like really in the weeds, but hopefully we'll get to see some cool stuff soon once I've gotten through all of this boilerplate.
Don't worry, Richard. We'll be your eyes.
Thank you.
You're welcome.
All right. Now I am looking at the sprite code off screen. Sorry, I wish there was a way for me to share both my screens without also showing my desktop where secret things can pop up. But unfortunately, technology just isn't there yet, you know? One day. All right. So our constructor for sprites takes in an image. So I'm actually just going to do I'm just going to pass in a dummy image so that it doesn't get upset with me. So I'm going to pass in a single pixel, which is going to be that. Now the function I actually want to overwrite in here is I'm going to first overwrite the draw function. One other thing, I'm going to make this take in a tile map. So I'm going to do a not protected, actually going to make it public map and it's going to be a tiles.tilemap. All right. Now, I'm going to make a draw function, and this draw function is going to be something that I'm going to copy from the sprites, but we're going to make it very different. So,
Richard, there was a question, but are you soliciting not this extension questions?
Sure, yeah, I mean, throw them at me.
Okay, what does bandwidth in the lanterns extension?
Oh, right. So in the lantern extension, you notice that the like effect is divided into a bunch of like concentric circles.
Yeah.
Right? So the bandwidth is the width of those circles, like in between the different levels of darkness.
So it's like the radius minus... Oh, it's just the radius.
It's the width in between the two, you know? So it's like the radius of one minus the radius of the other. Right? Like each circle has some space until the next circle. It's that space.
But the original circle... Oh, okay, yeah. I got you. Yeah. It's the width of the band. Thank you, Richard.
Yeah. Okay. So, we're now going to write our drawing code. So I'm going to get rid of this. We don't really need it. And we're going to draw something. So, important things. Oh, my indentation's messed up. I knew something was off. There we go. We need to actually draw our tile map to the screen. And it's not that tough to do it because we actually already have code for drawing our tile map. And so I'm just going to copy and paste that. Yay for copy and pasting. Man, am I going to write any code today? No one knows. All right. Okay. So I've got a lot of errors, and that's because I copied this from a different class, and it's got a bunch of stuff that, you know, I don't have. So I'm going to fix that up real quick. What I'm going to do is I named this map instead of underscore map, so I'm just going to go ahead and fix that over here. Oh, right. And it's actually not just map. It's this.map.data, I think. Do I have access to that? Darn it. Okay, so instead of taking a tile map, I'm going to take it a tile map data. There we go. Now we're happy. We're also going to take in a scale, and so this scale is going to be the scale from the tile map, and the scale is actually the width of the tiles. So this can be either 8, 16, or 32, just like it can in the tile map editor. All right, cool. Now this target thing, what am I going to do for that? Screen. So we always want to draw to the screen, so we're just going to be putting the screen here. Do you have another question?
Oh, no. I'm sorry. It's a secret button. It's hidden.
What's it do? Fine, don't answer.
So wait, that was a question? What did you say?
Yeah, I said, what's it do?
Oh, it's a secret.
All right. Mm-hmm. Okay, great. So, we've got this. We're drawing our tile map. Looks good. But actually, we're using the camera here, and that's not really what we want to do, because we want this platform to be somewhere in the world. So the reason that we extended sprites is because sprites have this really neat feature, which is they have an X and a Y. So what we're going to do is we're going to take this, everywhere we're doing this camera draw offset X and camera draw offset Y, and we're going to change this to be two variables we're going to make right now. So I'm going to make a new first variable, which is going to be draw offset X, and it's going to be equal to this dot X minus that draw offset X. And so this is going to take into account our X position, and it's also going to take into account our draw offset hex. Is that right? Should this be minus or plus? I think it's minus. It's one or the other.
Yeah.
All right, so I'm just, drawing this in here. Now we're going to take this. We're going to do the same thing, but with y. Oh, actually, I should be doing this dot top and this dot left.
Yes.
And now we're going to get rid of this camera and draw offset y. I just need to keep camera dot. I'm bad at typing. All right, cool. Now we have got our code to draw this thing. So that's neat. But you know what? I want to be able to test this code. So now we're going to go ahead and make our blocks. So we're going to make a block real quick. That's just going to be make a platform. And then we're going to be able to use that for testing. Now that we've got kind of the basic stuff out of the way. So to do that, I'm going to make another file. And this file is going to be called api.ts, which is just what I like to call the file where I put all of my APIs, all of my things that actually get used by the user. All right, so we're going to make a function now. And every block has a function. And the function is going to have some arguments that are going to get turned into the things that we see on a block. But first, what we need to do is we need to give it a name, and we need to, actually make it work. So I'm going to export this function. We're going to call it create, and it's going to take in a tile map. All right. Then what it's going to do is it's going to say new tile map equals new moving platform of that tile map. So we are just creating that class that we just made. So we're doing a new tile map, we're doing a new moving platform, and we've got that going now. So that works. One thing to know, though, is that right now this is not going to make it get drawn to the screen. We actually need to add it to do the scene, which is the thing in the background that actually holds everything, like all of the sprites and the physics engine and all of that stuff. So we're going to do game.currentScene.allSprites.push new tile map. And if we do that, we should now have it get drawn to the screen.
Isn't there an add sprite API directly on the scene? Is that different?
I don't think there is. Is there? There is. It's new.
Game.currentscene.
Hey, you're right. There is.
Yeah.
Cool. And so, like I said before, we made this so that it is a sprite. So we can just do this add sprite. And that works perfectly. All right, cool. So we've got this going. Let's go ahead now and call this. So we're going to go back to our test program.
Do you want to return it?
Sure, I guess.
Just so you can update its X and Y.
Yeah. All right, so now we're going to go over here. We're going to say test platform equals moving platform dot create, and we need to pass in a tile map. So we're going to type tile map backtick backtick, and as soon as we do that, that's going to give us this little symbol over here next to our line number. This little map symbol. If I click this, it's going to open up the tile map editor. Which actually, I'm realizing now that I probably, instead of doing this, I want to do an 8x8 tile map, just so that, it's a little bit smaller. So I'm going to do tile map 8 backtick backtick, and that's going to give me a tile map with 8x8 tiles. No need to import an extension. let's make this really garish, you know? All right, so this will be our tile. And we want to make this really small, so we're just going to make it like, I don't know, like, well, 4 is actually pretty good. 4 by like 1. There we go. That's our tile map. We need to make it a wall. And there we go. Okay, let's hit play now and see. We got nothing. Now the fun begins. We need to figure out why this isn't going.
Moving. So extending sprite, right? I need to go to sprite stuff. Yes. It might be like physics.add, scene.physicsengine.add sprite. That's the one we wanted, not the.
No, I don't want to do that though.
No. Oh. Okay.
So that tile map backtick returns tile map or tile map data?
Returns tile map data, I believe. Yeah, tile map data.
Okay.
All right, let's go over here. So let's get rid of this is out of screen. That could be the culprit. Nope. Okay. Now let's do the other thing. I said this was either plus or minus. Nope.
What
that's
if you
not it.
could it be behind the tile map? Is that possible?
Behind the tile map. It could be actually, yeah. So let's do this dot z equals 5. I don't know.
The default should be 0 for all sprites, unless you override it. All
right. Well, okay. So there's one thing we can do. We can use our trusty debugger. All right. So we hit this. We're gonna take a step now. All right. So we got into our code. So we're going to keep going. All right. What do our numbers look like? So draw offset x is 59. Draw offset y is 79. Those look like reasonable numbers to me.
That is correct, yeah.
All right. So we're going to step. Okay. So we're going into our wait. So our x0 is 7. Our xin is 4. That's not right. Okay. Wait. Okay. So our x0 is draw offset x tilde this dot map dot scale, right?
Oh, is scale scale is a 0, 1, 2, 3, isn't it? Or is that true?
Yeah. So that's right?
Yeah. Okay.
Mm-hmm. Okay, so that means we're dividing our draw offset x, which is 59, by 8. So that's going to give us 7, which is, 7, which is right. So for this next one, we're taking either our width or our this. Oh, shouldn't this be width plus x0?
Maybe.
Yeah, it should. It should be, right? Because this is the end x, so it should be x0 plus this dot map dot width.
Mm-hmm.
Huh. All right. Well. Okay, I don't know why that works, but sure. All right. So let's go ahead. We're going to turn off the debugger. We're going to make it so that our. Oh, right. that's because this is written assuming that the camera is scrolling relative to the
Tile map.
tile map, which is not in this case. So what we should be doing is actually just, this should be 0.
I mean, yeah,
It should
it should be
be-
width -1.
Yeah,
Yeah.
this dot map dot width, and then this should also be 0, and this should be this dot map dot height. And we can actually get rid of these variables, but let's just try it out first.
Mhm.
All right, not quite. So let's look at this code again real quick. So we've got our x equals x0. We're doing x minus x0. And then we're doing minus offset x. So let's see if we should be doing a plus here. Nope. And let's see, what are we doing? So let's hit the debugger again. We'll hit it right. So now we know that at least we're getting into this loop. So let's do our debugger again, and we'll set our breakpoint this time like right here. Okay. So let's look at what we've got. We've got our x is 0. We've got our y is 0. We're going to step over side of this. We're going to draw a transparent image. So x minus x0. Let's see, where's x0? Well, it's just equal to 0, so it's going to be 0 times this minus offset x. Offset x is equal to offset x is equal to draw offset x, right? So draw offset x is
Offset x is draw offset x down. Right. So
scaled down.
Scaled down, yeah.
Oh, no. Offset x is the amount that we have to shift it by.
Mhm.
So what we need to do is we need to take this, and we need to add our draw offset x. Yay. We're like so in the weeds. Yay!
Yay!
We got our tile map. Awesome. Okay. Do we actually need this offset x and offset y? I think not.
Yeah, I guess that's just to keep it aligned to 16 by 16 to 16 when you're moving around the tile. So it shouldn't need to. It's just drawing like a tile so it can be not aligned. That's fine.
All right, cool. So I'm realizing now I'm going to go back to MakeCode and I'm going to make my tile map bigger. And so that's just so we can scroll around and we'll see if this looks right or not. So let's just put in some random stuff. Whoops. There you go. Just got some stuff going on. All right. And we're also going to make it so that our we're going to do scene.camera follow sprite, and we're going to pass in the player. Hey now. I spelled it wrong. Cool. Yeah. Okay. This looks like it's working. You'll see it like disappears on the edge there. That's because we are not handling the width and height stuff right now, but I'm not going to worry about that. All right. This is cool. Cool. Okay. So we've got this going. I like it. What we're going to do now is we're going to write the physics stuff. So right now we just pass right through this like it's
Ghost.
Pass right through.
Right.
Like it's a ghost. Ghosts pass through you. You don't pass through ghosts. Okay. So we're going to go ahead and do some physicsy stuff to make it so that doesn't happen. So let's go back to our physics file, physics.ts. And the first thing we're going to do is we're going to put in a variable here, which is going to be platforms. And it's going to be an array of our moving platforms. And when we create the physics engine, we want to go ahead and say this is going to be this dot platforms is going to be an empty array. We want to make sure the array is there. Okay, one other thing, we're not actually using this physics engine right now. We're using the built-in one. So what we want to do is we want to make it so that we're using this one. We're going to go down to the bottom of this file. We're going to do game.currentscene.physicsengine equals new arcade physics engine. And this will make it so that we are actually using our physics engine and not the one that is built into arcade. Oh, sorry, actually, I just used the one that's built into arcade.
Yeah, you gotta move it up. Okay. Export it.
Did I not export it? All right, yeah, you're right. I'll just move it up. Putting it inside the namespace. There we go. Cool. All right. So now we're using our actual physics engine. And nothing changed, which is good because we just copied and pasted this code. So that's what we expect. All right. So let's go ahead. We're going to go into our moving platform code, and we need to add ourselves to that platform list. So when we create this, we're going to go ahead and do game.currentScene. We're going to do platforms. Oh, sorry, .physics engine. And now we need to do some stuff to trick our type engine into thinking that it is the right thing. So I'm actually going to cast this into any, and then I'm going to cast this into arcade physics engine. And this is just saying, hey, TypeScript, I know what this is. You don't, but I do. So make it this. And this is going to work out fine. In general, you don't want to. You don't want to do this for just anything because you might end up.
We're gonna need to export it anyway, if we're gonna use it across files.
Oh yeah, you're right. Cool. Okay. So now we are adding our platform to this platforms, which is cool. All right. So now we can use these platforms and we can do our collisions. So let's go into physics. And what we're going to do is we are going to take our platforms and we're going to call this tile map overlaps. Not tile map overlaps. We're going to call this, where is it? Tile map collisions code. That's right here. So for each of these, we're going to pass in the moving sprite, we're going to pass in the tile maps, and we're going to have to change this function a little bit to say what the tile map X and Y is. So let's see that. So we're going to pass in two new things here. We're going to do TM left. It's going to be a number. Do TM right. It's going to be another number. Not right, top. We've gotten some errors because we changed this function. It's being called other places. But because it's just being called where the actual tile map is, we can just pass in what the left and right is for, well, the left and top is for the actual tile map, which is 0, 0. Everyone's happy and we're not even lying. That's because, what's this stream about, Shannon?
Real true facts?
The truth.
Turks.
That's right. This stream is about the truth.
Oh.
Okay, let's see where tile map collisions is getting called. Right here. All right, so inside of move sprite. Looks good to me. So here we want to go out around to all of our platforms, and we're going to call this tile map collisions. So let's do that right now. We're going to do a for of loop, just like we always do. Platform of this dot platforms, and then we're going to do this dot tile map collisions, of ms platform dot map, and then platform dot left, platform dot top. Did I not export this? Oh, it takes in an actual tile map. Is it just taking in the tile map so that it can take in the tile map data?
Probably. I guess the scale.
All right. Well, we can do this. So for now, let's just write some code to make this work. What we're going to do is we're going to, where was I just? Where at? There we go. Okay. We're going to say const temp equals new tiles dot tile map of tm. Of platform dot map. Well, I did mean that. Thank you, type checker. Okay, and then let's see, temp dot set data platform dot map. Awesome. And then temp dot, looking to see if there's like a destroy or something, but it doesn't look like it. So, all right, we'll just leave it like that for now. Now we're going to pass
move
this.
the temp. Could you move the temp initialization out of the for loop?
Yes, thank you.
Sweet.
And we're just going to hard code this for now. We're going to say tile scale dot 8. That's what we're doing. All right, cool. All right. Still nothing's happening. And that's because we are actually doing this based off of we didn't actually use those two things that we added, the platform.left and platform.top, right? So of course it's not going to work, of course.
Wait, so can you collide with it if you jump all the way to the top left? Or
let's see. Huh. Shouldn't I be able to?
Or bottom
See, I
left?
think tile map collisions was called one other place. Oh, right here. Oh, no. Right here. So let me copy this code that I just wrote. I should put this into a function. All right, I call it there too. And whoa! All right.
Is the act of calling the tile map constructor doing something?
So it is creating the sprite up here. But that's not actually what I'm concerned about. The thing that's weird. Let's see, is it really not a temp.destroy? Okay, then we're just going to do game.currentScene.allSprites.remove element.
Wait, it's not a sprite.
I thought tile map was.
I think it has a a field that's a sprite maybe. I remember there's something weird about it, but I never touched. I didn't like it. There they go.
Oh, indeed. It creates a renderable.
Ah, okay, we did touch that. Well, it creates is the renderable exposed? Is it
it's not.
No.
Okay. That's okay. We're going to do this. Fake tile map. Fake tile map has a draw function. Doesn't do anything. It's a silly function. All right. Now what we're going to do is we're going to do this. Nice. All right. Now here, we're going to say now we're going to look for temp. Go away. We're going to do this dot fake tile map. Sorry, test tile map. Like that. Get rid of that. And now we have solved the problem. Because that's what we're all about on this. Telling the truth, solving problems, you know?
That's a new one, Richard. I don't know. Are we ready to sign up for another thing?
I think so.
Okay.
All right, cool. So it's not being drawn up there anymore, which is great. So why can't I move? Well, I was thinking about this. So we're outside of that tile map right now. And everything outside of a tile map is a wall.
Mm. But you should still be able to. It shouldn't be preventing you, right? Because it should be doing the clipping.
No, it won't clip because I am the clipping is getting cleared in the other tile map.
Oh, yeah. I like that.
Yep. All right, so we're gonna have to do something a little bit different than what we were doing before. It's okay though. We're gonna take our tile map collisions code right here. We're gonna collapse it. We're gonna copy it. We're gonna paste it. We're going to call it platform collisions. And we're going to go ahead and get rid of these things we just added because we don't need them anymore. We're just going to leave this one as it is, and we're going to call this platform collisions instead.
Ship it.
This is probably how I would have done it if I was like writing this extension, you know, not live. I should have looked at my code for how I did this the first time around, you know, because I've written movable platforms before. I think I mentioned this at the top, but I just did it in a different physics engine. It was a while ago. Nice. Okay. Other thing we're going to do real quick. So inside of our fake tile map, there's a function called isOnWall. All right. Oh, actually, we want to take this isObstacle. That's what we want to overwrite. Yeah, perfect. Okay, so we want to take this isObstacle. And so right now we're saying if isOutside map return true. Nah. There we go. Cool. Now look, it's working like we thought it would. Yeah, so I can't go up in this corner here because that tile map right now is up in that corner. And And so it's ignoring it, which is great. It's working perfectly. All right, so let's go down to our platform collisions now, and we're going to fill this in. It should be pretty simple. So we're going to go into here. Okay, we're going to go into this platform collisions, and we're going to take our hitbox, and well, actually, no, we won't do that. We'll just go into our where we're actually checking the is obstacle. Right, okay, so we're taking this is obstacle function, and we're calling it, and we're passing in our x0 and our y0. So this is the location of the column and the row that we're doing. So we want to change how we calculate this column and row to keep in mind where the tile map is. So let's go up to where we're actually calculating our x0 and we're actually calculating our y0. It's right here and right here. And so you know how I said before fx8 is just a number? It is. But we have all these functions to do all the stuff you normally do, like plus, minus, and all that stuff. That's what's going on right here. So right now we're doing this 2-inch shifted to get the x0, but we want to actually add some stuff to that to make it so that it's keeping in mind where it is relative to where this camera is. So we're actually going to take our right, and we're going to do our right as this, and we're going to subtract the TM left. Is that an FX8?
No, that's a boolean. Like that's saying
that's
is
a
this
boolean.
going to the right?
Gotcha. So right here, we're going to do that. Well, this is a FX8, right? Yeah. So we should probably just take an FX8 here. Which is fine, because we actually store the left and the top as FX8s on sprites. You just don't see it because we put this underscore on it. But if you underscore X underscore Y, that is the left and top. But in FX8 format. Yay. All right. Let's go back to where we were before. It's like right question mark. Not this one, though. No, wait, was it that one? Yeah, here we go. And we're going to take this right, and we're going to do fx dot sub right with tm left. And we're going to do the same thing down here. But we want to change this to be left. All right. Yeah, we're going to do the same thing here. So we're subbing our hbox bottom, but we actually want to take this, and we're going to do hbox.bottom and tm top. And then, do we do the other one somewhere else? So we're checking the top here. Where do we check the bottom?
Checking the top.
Oh, I think we just loop over it.
Yeah, it's just going the other way.
Yeah, we're fine. Cool. All right, so the last thing we need to do is that when we do this collision resolution, so this is where we actually do the pushing out. So for this, we also need to handle subtract to those things we were just subtracting. So let's go ahead now. We're going to go to where we are setting its, all right, so if we're doing this, we're setting our X. We want to set it to this, and then we want to add.
Oh. For anyone watching, just note that this isn't the ideal code right here for the physics engine, and the only reason why this is such all-in-one function as it is because it makes like a 4 frame per second difference on hardware.
Yeah.
To have it all in one giant mess of a function instead of split up into sub-functions, which
Here,
was very
all
sad
about
for
that
me.
perf. All about that perf.
But it was a nice upgrade. It's like 10% boost.
Yeah. All right, so we're taking this number, we're doing this x0 times tile scale, and then we are adding the left so that we're aligned correctly. We're going to do the same thing here. We want to add our left to this biz. Nice. All right, let's do it for the Y. Okay, this is just changing our velocity. We don't need to mess with that. All right, so now we're here in the Y diff. So just like before, everywhere we see this bottom and everywhere we see this top, we want to go ahead and do that subtraction. And I really hope this works first time. I think it's going to. All right. Okay, then we're checking the obstacle, and then here we're doing that same thing again. We are subtracting and figuring out where our Y should be. So yeah, I'm realizing now I could have just done this. On the last one. But oh well, there we go.
Yeah, that would work.
Okay, and then we have this tile overlap stuff, which actually, goodbye. No tile overlaps in platforms, sorry. All right, cool. Oh, our drawing code is off, I think.
Oh yeah, we did set that to be the center of the screen.
Yeah, our drawing code is off, but I think our collisions are working correctly.
It looks like it.
Yeah.
Nice.
That's cool.
Maybe that point, that place where we put a plus, it should be a minus.
Yeah, maybe. Let's try and fix that. Eh? That didn't even change anything. Oh no, that's definitely not right.
It's a moving platform.
Yeah. Transparent image. This x minus. Well, we might as well get rid of the x0, y0 from that equation just to clarify it a little bit, because the x0, y0 is just.
Yeah, it is confusing.
Maybe.
Okay. So we're scaling up the x, and then we're adding the offset.
Yep, okay, so this is just saying x, but we're converting this basically from tile units into actual pixels. So this is going to multiply x times 8. Then we're adding this draw offset x, which is where we should be drawing relative to. So we're taking our top, we're subtracting the,
Nice.
Top and left split. Okay.
all right, cool. Well, so we actually got pretty far, which is pretty good. We don't have the platforms moving yet, and as this is currently written, this isn't going to work for moving, because we have some other stuff we need to deal with. Mainly, like, if we land on this and it's moving, we want to move with it. You know, we don't want it to just move out from under us. And if it moves into us, we don't want to start clipping. So we've got some stuff to do with that. But I have an idea of how to do that, and maybe we'll do it next Friday or next time we go back to do another JavaScript stream. Till then, I'm Richard, at Richard on the MakeCode forum.
I'm Daryl, at Daryl on the MakeCode forums.
I'm Joey, at JWonder on the MakeCode forums.
I'm Shannon at Checkout on the MakeCode forums.
And I'm Vivian at Live Cheerful on the MakeCode forums.
All right, and I hope you enjoyed this look into the advanced side of Arcade, the messy internals that Joey and I wrote, and other people as well. And we will let us know on the forum if you liked this. If you liked this, we can do it on some Fridays every once in a while. Yeah.